Mike can finish a job alone in 40 days. If Ike works on the job for 10 days and Mike joins in on the 11th day, they can complete the job by working together for another 20 days. How many days would it take for Ike to finish the job if he worked alone? Alright, well, this is a basic rate problem, maybe not so basic, but we're essentially given Mike's rate, right? Because Mike, let's see, let's write down Mike. And his rate, he can finish a whole job in 40 days. So that's one job per 40 days. Okay? So that's the same thing as 1/40th of a job per day. Okay? So that's his rate. That's how fast he works, okay, in jobs per day. And we're asked to find Ike's rate, essentially, right? How long would it take Ike to finish a job if he worked alone? So we're given Mike's rate. Now we're given some information about Ike and Mike working together here. So Ike works alone for 10 days. And then Mike joins him on the 11th day, and then they complete the job for after another 20 days. So, in this scenario, Ike is working for a full 30 days, and then Mike is just working for 20 days. All right. So I'm going to assign a couple of variables. This is the Mike's rate. I'm going to call it RM, and Ike's rate, I'm just going to call RI, which is essentially what we're trying to find. Only we're actually looking for how long it takes him to finish a whole job instead of how many. But so anyway, if we find Ike's rate, then we can find how many days that it takes him to finish a job. Okay, so let's put this thing together. All right, so if we knew Ike's rate, I'm just going to write for right now. I'm just going to include the variable because I don't know Ike's rate. That's what I want to find. But if I knew his rate, and I know that he works for 30 days, that would tell me the portion of the job that he's able to complete during this time period when they work. Okay, so Ike worked for 30 days, but then also Mike worked with him for part of the time, but only 20 days. So Mike's rate is 1/40th of a job per day, right? Jobs per day. So I could include the units if I wanted to. But if I take that times the length of time that he worked, which was 20 days, okay, then I get the portion of the job that he completed, okay? And in the end, they completed one job, right? They completed the job in, by working this way. So Ike worked for 30 days, and Mike worked for 20 days, and they were able to complete it. And you can see now I've got only one variable, and if I solve for Ike's rate, then I'll be able to figure this out. Okay, so all right, so here I got 1/40th of times 20. Okay, so that gives me what? That's just a half, right? So actually, during the time that Mike works, he's able to actually do half the job. All right, so that means that Ike did half the job in 30 days. Okay, so let's do this. So let's just rewrite everything. This is 30 RI. Okay, and let me scroll down a bit. So now I can solve for RI. If I subtract the half from both sides, okay, then 30 days times Ike's rate is equal to 1/2. And if I divide both sides by 30, then I get that Ike's rate is actually 1/60th of a job per day. Okay, so he can complete 1/60th of a job each day. So obviously it would take him a full 60 days to complete one job, which is what we're supposed to find. How many days would it take Ike to finish the job if he worked alone? So the answer here is that Ike could finish the job in 60 days.